glad to be here today on another section of our presentation. Normally we have a YouTube channel where we contribute to the world in several different topics in the areas of mathematics, and today we are grateful again to be online sharing new methods in the area of quadratic equation topic. So it's my YouTube channel. Kindly keep following this channel. I'm here to offer you the best you need in the areas of mathematics. After watching the video, just click on subscribe to my channel so that every time I upload a new video, you will have an alarm. And I also say many thanks to my subscribers, people who are always watching my video, sharing my video across the globe. I'm so grateful to you, and I say thank you for sharing and following and your comment, and let's stay connected as we take the word of mathematics to another possibility. Thank you, and let's solve our problem. This is our problem on the board, and I have derived a new method that will help you to solve this problem. Now, here's the question. Our topic is quadratic equation, and it is mathematics tutorial, like I said, Dolo S YouTube channel. And the question here says, find the quadratic equation whose roots are 1/2 and -3/2. So this is the problem. They have given you two roots of the quadratic equation. There are several methods in getting the equation when the roots are given. And the method we're going to use it to be a very simple, short method, and it's a very sweet method, and you will really love using that method. And that method is called the Dolos Equation, a very sweet and short equation that I derive. Now, to solve this problem, the first thing we got to consider, we consider our data. So now we say data. Come down here and say our data. But in having the data, there are a few things we need to consider. Now, in our data, the first thing I want you to understand why you are using the method I have derived to solve this problem in the equation. The first thing, let's consider R1. R1 is the first root of the quadratic equation. R1 is 1/2, 1/2. So we're going to express data in the form A/B. Yes, very simple. So we're going to express R1 is A/B. So we're going to be considering A/B for our data. Now we also say R2 is also -3/2, so it's -3/2. And let's say it should equal to C/D. So this is what we're going to use. So from this we see now, we can say A will be equal to, this is the position of A here. So because we say R1 is equal to A/B, so it's 1/2, so it means A is equal to what? 1. Then B here has the position here. The denominator of R1, which is B, is what? 2. Now we are done with the first root with 1. Then we come to the second root. Now in the second root here, we got -3/2, and we said we're expressing it as a fraction C/D. So we got C/D to be R2, that's our reasoning, and we got -3/2. It means that C will be equal to -3. So in our data here, we say C will be equal to -3 or -3, and D, that is the denominator of the second root, is the position of 2. So the same position here is the same, so it's what? Possibly 2. So this tells us that R1 is equal to A/B, that means 1/2. So A will be equal to the numerator of R1, B is the denominator of R1, we capture it, which is 2, A is equal to 1, B is equal to 2, and C is equal to -3. That's the numerator for the second root, R2, minus 3, and d here is equal to positive 2. This is the denominators of the second root. So we have already captured our data. Now we can go to the Dolos equation. So we are about to solve our problem, but like I said, the method we are using, or the equation we are using, is the Dolos equation. So we say the method is we are using the Dolos equation. Maybe somebody may ask about the Dolos equation because this method is being derived by Dolo S by me. So it's a very easy equation. So it's the solution. Now, there are a few things we have to capture. We said the first root in our analysis expressed as A or B, and the second root is expressed as B, C or D. So to use the Dolos equation, we say the equation, let's say equation, the entire equation. The equation is parenthesis open. We multiply the two denominators. So that means we say the denominator of this second root arrow 2 times the denominator of the first root. That means db equals against the square of x minus the braces open. When this braces open, braces open, parenthesis open. Now we multiply the denominator of arrow 1, the first root, times the numerator of the second root. So this means we'll have b, c equals plus another parenthesis open. Now we say the denominator of arrow 2, the second root, times the numerator of the first root. So we say d a equals then we now close our braces all against x plus parenthesis open. Now we can multiply the two numerators. Arrow 1, the numerator of the first root times the numerator of the second root. That means a, c equals must be equal to 0. This is the Dolos equation. This is the Dolos equation. Let me adjust this. This is the Dolos equation. Parenthesis open, db equals against x squared, the quadratic of x, minus braces open, parenthesis open, bc, parenthesis closes, plus another parenthesis open, dA equals braces close against x, plus parenthesis open, AC equals 0. Like I said, D is the denominator of the second root 2, B is the denominator of root 1, and A is the numerator of root 1, likewise C is the numerator of root 2. So this is the Dolos equation. You can use the equation to find the quadratic equation on any given root. So let's keep our problem solved. Getting the Dolos equation. This is the Dolos equation. So to solve our problems, our next step, we just get into our data. This is the data. We just get into our data where whatsoever we see the values of D, we just get our values of D in the data and place it there like the others, letters, and then we just skillfully solve our problem. Now let's do it. So this is D and B. Let's check in our data and get the values of D and D. Now B is equal to 2 and D is equal to 2. Now, D is equal to 2, so we say 2 parenthesis open. B is equal to 2. That these are the numerator of the first of root 1 and the denominator of root 1 and the denominator of root 2, or again S squared. So minus braces open. Then B, let's get B from the data. B is equal to 2 and C is equal to minus 3. So we substitute for B and C. So B is equal to positive 2 times C is equal to negative 3. We close it. Plus. And we got D. D is equal to 2 times A in our data is equal to A in our data is positive 1. So we just get the value. We just get the value substitute for A. So A is positive 1. And basis closes all against X plus A here we got is just positive 1 time C here, as you see, C is minus 3 or negative 3 must be equal to 0. So now we can apply our common mathematics very easy to use the Dolos equation. So 2 times 2 is 4. 2 times 2 is just 4 against S squared. So we can put a 4 in the parenthesis here, no problem, because BD against S squared minus, we still maintain the braces because we got to D within before we can perform our operation. So braces open. 2 times negative 3 will give us negative 6 plus 2 times positive 1 will give us positive 2. Let's change the braces to parenthesis. Parenthesis closes, parenthesis open close against X. So we got positive 1 times minus 3 will just give us minus 3 must be equal to 0. So after we are done with this, 4 times S squared will just give us 4 S squared minus 4S squared minus parenthesis open, we gotta deal with the parenthesis first. Minus 6 plus 2 will give us minus 4 or again X minus 3 equals 0. So finally we got 4S squared negative times negative 4 again S will just give us negative, we got positive, negative times negative 4, we got positive 4 again X will give positive 4X. Negative times negative 4X will just give us positive 4X minus 3 equals 0. This is the Dolos equation result. This is our result. So our final result is, let me skillfully do this, I'm so sorry. Alright, this is our equation. 4x squared plus 4x minus 3 equals 0. 4x squared plus 4x minus 3 equals 0. So this is this is the equation for the roots that were given us 2 over 3 and minus 3, 1 over 2 and minus 3 over 2. So you can enjoy using the Dolos equation. We have done with the Dolos equation. This is our final equation. 4x squared plus 4x minus 3 equals 0. There are several other methods that you can use to get this equation when you are given the roots and they ask you to find the quadratic equation. You can use a lot of methods, and this is my contribution towards the field of mathematics, to be specific in the topic quadratic equation. So thank you so very much. You can use this equation, the Dolos equation, to find a quadratic equation whenever you are given the roots. And this is the equation, the question, and we have two roots, 1 over 2 and minus 3 over 2. We selected our data. We express it root 1 in the form to be A over B as a fraction, and root 2 to be C over D. So this is the Dolos equation. Kind of enjoy using the Dolos equation as we keep following solving my problem. Thank you so very much for watching this video. After watching this video, kind of subscribe to my YouTube channel, like, share, and comment my video. Comment on my YouTube channel. Please share on other social network site. Share on Facebook. Share on any other social site. You can also follow me on Facebook, my full name, Dolo S Tokpah, on YouTube. Just go on YouTube, just check my name up, Dolo S Tokpah. You will get me live on YouTube, on Facebook, on Twitter. You'll follow me up. And I want to say many thanks to my subscribers, those who are always following my video, those who are always commenting on my videos, sharing my video. I want to say thank you so very much. I am grateful, and please keep following, share my video. Let's take the word of mathematics to another world. So it has been a pleasure, and I want to appreciate my director in person of Mr. Benjamin George. Thank you for having my back, and all those colleagues who are always standing by me in this process. We believe that mathematics is innovation, and as such, we must be able to take mathematics to a new world. Maybe someone may say, "Well, why the guy have to use his name on the equation?" It's my innovation, and there are several other videos right now. I have over 9 videos online. This is 10th video I have online on YouTube, and I've been innovating. Check on YouTube. You'll see the Dolos pattern. The Dolos pattern, it was developed by me. The Gaussian Dolo elimination, my third video, several other methods. All my videos are new creation. Our goal is to create an enabling environment where young people, both old and young across the world, will be able to get on their feet, create, and as such take mathematics to the new world. Carl Frederick Gauss, Isaac Newton, all the great mathematicians did likewise. That's why you got a Newton third law of motion. It was derived by Newton. He discovered by Newton, and he named it after him. The Gaussian elimination was a method in solving linear equation 2 variable, derived by Carl Frederick Gauss, and he named it after him. So we ourselves can do likewise. So keep following, and we are open to partnering with people across the world. People to partner with us in terms of maybe sponsorship or a program seminar. We are always open to that. Thank you so very much, and God bless us all. Thank you so much.
Your holy name.